Okay, today's lecture is going to pick up where we left off talking about parental care. We had talked a lot about incubation behavior and laying of eggs and clutch sizes and developmental modes between altricial and precocial. And today we're really going to focus on once the eggs have hatched, and particularly in altricial young, the parental care that happens at that stage. So it's going to be a lot of that is going to be feeding. Energy and nutritional needs increase as a young bird develops. So as it gets bigger, of course, it's going to need more and more food that will fuel its continued development. And that includes nutrients like amino acids for the production of protein and calcium for the production of bones. As far as the amino acids, the key source of protein for most passerine birds, even non-passerines, are some kind of animals, and that oftentimes is insects. So insects really are a key part of the diet, even for frugivorous birds and nectivores. Birds that feed primarily on fruit or nectar much of the year will feed on insects or some other kind of arthropod. So hummingbirds, for example, will gather spiders and insects to feed their young. Remember early in the semester we talked about the crop and how it's used in storage, but in some birds it produces this sloughing off of the lining of the crop that's high in proteins and fats. It produces this milky substance called crop milk. It's used to feed the developing young in birds like some penguins, flamingos, most widespread, most commonly known in columbiforms, doves and pigeons. Okay, well, how much do these birds need? For a small passerine, we're talking about a lot. So 4 to 12 trips per hour. If it's a cavity nesting species, they tend to have larger clutches because of less predation risk, but remember that was one of the things that can lead to a relaxation of the predation pressure, which is the most common reason why nests fail. So if it's a little bit safer in a cavity nest, you can lay more eggs, but when those eggs hatch, you got to bring more food to more young, and so they have even faster rates of delivery of food compared to open kept nesters. Larger birds, maybe a tenth of what we're talking about here, so maybe 5 to 12 trips per day instead of hour during the daytime. Usually those are larger pieces of food, chunks of food as well. Now, some large seabirds may only bring food in really big batches again, 1 to every 2 to 3 days, so much reduced rate. Those birds tend to be developing more slowly over a longer time period as well. Now, the rate does increase as the nesting age, as their digestive tracts become more efficient and able to digest that food. More and more is brought. But just prior to feeding, the rate at which parents bring food to the nestlings drops, and that's for an important reason. Remember, we're talking about some of the terminology. A nestling is a bird that's in the nest. A fledgling is a bird that is leaving the nest. And it's important for birds to leave the nest, particularly if the parents need to start getting ready for migration and building up their own energy stores for that reason, or maybe laying a second clutch of eggs. But regardless, there gets to be a tipping point when they've invested enough at that stage and they need the young to leave the nest to see how many of them can be successful fledglings. And one of the things that they do to encourage them to leave the nest is they stop feeding them as much. And they actually will hold food out of the nest to entice them to leave the nest. I've seen scrub jays do this, so it's a pretty common ploy. The delivery rate that parents will bring the food, though, is also influenced by the nestlings themselves. The begging vocalizations you hear baby birds producing triggers the parents to basically act like robots in many cases, and we'll talk about this when we talk about brood parasitism next week. But that can increase the rate of delivery, And the synchronized begging of nestlings in some species is even more effective at spurring the parents into feeding. Now, those vocalizations can also be used in some cases to give a startle response to a nest predator, maybe make them back off and kind of think about what they're doing, and also may give the parents just enough time to hear that their nestlings are in trouble and come to attack and protect the nest, and perhaps produce mobbing calls to bring others to the defense of their nest as well. So we've talked about the importance of predation in limiting nesting success, and how that is the reason why most nests fail. Well, you would think begging birds are going to more likely draw attention to the nest. So here's an experimental study to show that begging is more likely to attract nests, particularly in ground nesting species. So if you compare in this experimental study where they had some artificial nests that were silent, and other artificial nests where they had tape recorders playing a vocalization at these nests. What they found is that those that were preyed upon differed in the two classes. So those that didn't have begging young, that just had, I think that what they did is they baited the nest with eggs in this situation. The ones that had begging to draw attention to the nest showed predation, much higher predation compared to those that were just randomly stumbled upon by predators in the silent treatment. Now, that was clearly the case, as you can see here, for ground nesting species. Tree nesting species, though, it didn't make a difference. There was no significant difference between these. So remember, that's one of the things we talked about, is the higher you go, the safer your nest is for predators. And this is another kind of demonstration of that. Well, kind of building on the idea that, yeah, ground nests, begging's not always good. So, but you got to beg to get the parents to bring food to you. So what would be maybe the optimal begging rate? And where does predation rates begin to drop off and you can still beg for food? And here it shows that it really does depend on the predation rate. Just if you look at ground nest, sure enough, if you have a higher call rate, you're more likely to have predation events compared to a low calling rate. So there is selection to minimize this and only beg when the parents are, say, at the nest and you're trying to get them to give you that food. There's other signals that the nestlings can communicate their need relative to food to the parents, and that's the coloration of their gape, the lining of the mouth. But interestingly, studies have indicated that the specific information that's been communicated can vary from species to species. So in some species, the nestlings with the brightest or the reddest gapes, that's basically an indication that they are of high quality, they're good individuals, and that you should give them more food. That they're doing pretty good, but you need to invest more into them because they're more likely to survive. And this is maybe what the parents want to do if not all the nestlings look like they're going to survive. Maybe cut their losses with some. Well, in other species, it's been indicated that you need to feed the nestlings with the gape that indicates the opposite, the greatest need. So if there's a decent chance that all of the young can survive, there's enough resources to go around if you kind of proportion it out appropriately, then every time you bring some food, you need to give it to the nestling that needs it the most at that time period. And that again, might increase the likelihood that all of the young are going to survive. So these two different ways in which coloration can be used by parents to allocate food to nestlings could vary from species to species or in different environmental contexts with limited or abundant food availability. There's a potential other reason why gapes may be colored in species, especially in some lighter colored gapes. They may actually help the parents kind of find the nestlings under the very low light conditions of a cavity nest. When we talked about vocalizations, we talked about the importance of having individual variation in vocalizations, or kind of family level variation in vocalizations of begging young, and so that the parents can recognize which whole belongs to them, and when the young fledge, which of the fledglings belong to them based upon their vocalization. And I mentioned that they had demonstrated this in studies of bank swallows by actually taking the young out and feeding them artificially, but then putting different vocalizations of different nests or the same nests in different holes, and seeing if the parents would say, oh, yep, I hear my young coming from that hole, and they go into their normal hole. Or if you move it, then do they go to their normal hole, which is maybe silent or has the vocalizations of another family that's been artificially placed in there, or do they search out and find the nest hole that has their vocalizations? And that's what they do. They are driven by the vocalizations that they can recognize that belongs to their nestlings. And as I mentioned previously, species like northern rough-winged swallows, which are solitary, they don't have this ability to discriminate because they're not nesting in these colonial situations, and so there's never been a selection pressure in which they're likely to make a mistake. If they see a baby bird, or if there's a nest in their territory, that's obviously just going to be theirs. Now, in species that have large broods, there can be stress in times of low food availability and high food demand. And there are a couple of ways that species have evolved to deal with these situations. Some show what we call developmental plasticity, so that the young can actually slow down the rate of their growth, spread that out over longer periods of time, and allow the parents maybe to bring just enough food to keep them alive and to grow more slowly. In some cases, though, the increased food demand can lead to a high degree of sibling competition, where siblings are competing with each other to get that limited amount of food. And this can lead to what we call brood reduction, so that some of them are going to die by either active or some kind of passive siblicide. So let's talk about siblicide. So again, brood reduction is seen when you see the number of nestlings that survive to fledge is less than the number that hatch, so the brood has been reduced somehow. And siblicide occurs when the nestlings contribute to that pattern. So they either outcompete their nest mates for food, and so indirectly they cause their nestlings to die, or they can physically attack their nest mates to try to kill them. Now, what's interesting about siblicide is the parent can sometimes be at the nest when it's occurring, and they just let it happen. You know, they bring food to the nest, and maybe they just, whoever's the most aggressive, that they're going to get the food, or if they're pecking each other with their bills and stabbing each other, the parents will just sit there and let it take place. So we have to ask, why would they do that? I mean, if these are their young, they've worked really hard to build this nest, to find appropriate mates, to invest in these gametes, and to invest in the nestlings through the incubation phase and this at least initial feeding phase to get them where they are. Why would they let them kill each other? Well, there are two circumstances in which siblicide that leads to brood reduction might actually be adaptive. So let's say that a species nests normally in a highly variable, unpredictable environment, such that when you lay your eggs, you don't know if there's going to be enough food available when the young hatch and you're having to feed them. In a situation like that, maybe the species collectively has evolved some kind of optimism, basically. Think about it like that, where they lay the number of eggs that could be raised in a good year. So that if it is a good year, great, you've maximized your reproduction. However, what happens though, if you have laid enough eggs for a good year and it's a bad year, there's really not enough food to go around, in that situation, if you did try to spread the food out among all of the individuals that hatched, maybe half of them would die, or a substantial number of them would die from starvation because there just wasn't enough food go around. So in those bad years, if there was a mechanism that allowed the brood to be reduced to fit the food supply that's available, and only the strongest survive, that's actually in the best interest of both of the survivors and the parents. So one of the things that can accentuate the possibility of this occurring is asynchronous hatching. Remember, we talked in the last lecture about the patterns depending on when the parents start incubating the eggs. Do the young hatch at the same time, synchronous hatching or asynchronous hatching? Well, in species that oftentimes do show siblicide, they show a pattern of immediate incubation with strong asynchronous hatching, so that there's a huge range of sizes and developmental stages associated with a brood of young. And that's what's being shown here in this pretty pink bucket that we found in Taiwan to collect these nestlings as we were taking blood samples from them. These are all nestlings from the same nest of blue-tailed bee eaters. And you can tell that this is the oldest individual, maybe a day behind, maybe a couple of days behind, several days behind that, and this poor guy way, way behind. So it turned out in this year, when these nestlings were taken out of their nest to take blood samples, that we put them back after they were measured, and every single nest that wasn't depredated in this year, all of the young survived. So they all fledged successfully. So it was actually a good year for food. So this little guy right here actually did survive. However, if it would have been a bad year and there's only, say, enough food to feed 3 nestlings, well, guess what? It's going to be this guy, and this guy most likely. They're the ones that are more mobile. They can peck their nest mates, and they did have these very sharp kind of hook-like bills that they could attack each other with early in life. But the other thing is they nested in cavities. Let me see if I can draw this. So if this is, oops, no, I need to do it this way. So if this is like a cliff face and there's a pond here, okay, that's water, they would excavate cavities with a little nice chamber at the back. And when they first hatched, like this guy right here couldn't move very much. And so he would be just back here sleeping, right? Well, these individuals would come to the front of the nest and they would camp out and get all of the food that mom and dad were bringing to the front of the nest. But in a good year, mom and dad bring them enough food that they get sleepy and they say, I'm gonna go take a nap. So they go back here, and that eventually leaves time for this individual to get up there and get its share of the food. But if it was a bad year, man, the big individuals would basically just elbow out this entrance and not allow their siblings to get any of the food. And so it's kind of a combination of passive and active siblicide that could occur in species like blue-tailed bee eaters. So that's one way asynchronous hatching and brood reduction via siblicide could be beneficial. In those bad years, you shoot for the moon. If it's a good year, great, everybody survives. It's a bad year, you've put in place a mechanism such that only the strongest survive. Here's another potential hypothesis it's a hypothesis that it has some support in some species for brood reduction under certain circumstances being adaptive. Species like red cockaded woodpeckers have relatively high hatch failure rates. So a lot of the times you go to collect data at a nest and you see that one of the eggs doesn't hatch. Okay. Well, in a situation like that, species that's a fairly regular thing, they may lay extra eggs as insurance eggs. Okay, so just in case, if a clutch is likely to succeed at 4, you may lay 5 eggs. So hopefully that 4 of those will hatch. But oops, what happens if all 5 hatch? Well, there may not be enough food to go around again. And again, you have to have some mechanism to set up efficient brood reduction so that only the strongest survive. And again, that is what we see in species like red-cockaded woodpeckers. They also show clearly, as you can see here, that's the oldest individual, a couple days behind, a couple more days behind, and then an egg that didn't hatch in this nest. So those insurance eggs can help assure that you get an appropriate clutch size. But if you do happen to overshoot it because they all hatch, then brood reduction allows only the strongest to survive in that circumstance. So we talked a lot about how monogamy is related to biparental care in birds, and that kind of makes it seem like the parents are working together to raise that clutch of young. And that's why there's so many monogamous species of birds and why biparental care is so closely linked to that. But I don't want to give the impression that both of the parents are working the same as far as how hard they're working in that regard, or that they're willing participants in that. Both are looking out for what's best for themselves. And if they can reduce their amount of work and make their partner do more of the work, that might be in their best interest. So both males and females will try to minimize their own effort. Males would be particularly likely to do so if they suspect that they don't have complete paternity assurance. So males in species that have high extra-pair copulation rates will adjust their parental care levels based upon how confident they are that they are the father of all of the young in the nest or a certain percentage. So common reed buntings, if they spent a lot of time away from their female during her most fertile period of time, unable to, say, mate guard her or searching out their own extra-pair copulations, they will spend less time feeding at their own nest because they may not actually be the father of most of those young. But in situations where they have greater assurance of paternity, they will actually contribute more. So, related to the idea that parental care is costly and males and females will slack up if they can force their partner to do more, and that will actually help them in their health and lifetime reproductive success. Here was a study done on blue tits. Blue tits typically, like most passerines, show synchronous hatching of young. Now that requires biparental care because you go pretty swiftly from incubation to feeding, and so you have a lot of mouths to feed all at once, and mom and dad both have to work really hard to do so. And what you see in these different years, 4 different years, and here's kind of the summary of it, is the survival rate of the parent under these circumstances fairly good for the females, and I say fairly good, some years not, less than 40%. But the males tend to have lower survivorship, probably not significantly different in this year. But the overall pattern is males don't do as well under a pattern of normal synchronous hatching. Well, researchers can artificially create asynchronous hatching by taking away some eggs when incubation starts and then adding them a little bit later. So that they kind of get a slower developmental, or they're kind of behind the curve as far as development goes, so that it just produces eventually an asynchronous hatching. But this is an experimentally induced thing. It doesn't happen in nature, but they're doing this to show you the consequence of that for males and females. In cases where they experimentally induced these to be asynchronous, the male basically slacked up. The eggs were hatching more slowly, and the female could bring enough food to care for these young, so the male basically just kicked back and didn't do as much, and he had relatively either comparable or higher reproductive success, or survivor, compared to the female under these circumstances. So this is just showing you that these decisions can be kind of a dynamic thing in these species. Let's talk about sex ratios in nests. In general, in a population of sexually reproducing animals, it's about 50-50 males and females is what we call the initial sex ratio. Operational sex ratio can vary because of increased mortality of males, say, so that you have a female biased population. But usually at hatching, you're about 50-50 in most species. And there's some mathematical models that kind of show why that would be the case. But that may be true at the population level. But at individual levels, there might be circumstances in which it would be better for a female to bias her clutch to produce more males or more females. So here's an example of such a study in red-winged blackbirds, in which young females who are just really not high quality yet, and they may not be the best parents yet, they can't produce the highest quality eggs, maybe not have the richest yolk or the greatest amount of yolk, and they probably are not the best parents, can't bring enough food to the young. They really can't deal with the faster developmental rates associated with males. And so they actually bias their clutch to produce more females than males in that circumstance. One, because they're, again, more likely to be able to keep up with them. But if you produce a low quality female, she's still probably going to have some reproductive success in the future. If you produce a low quality male in a red-winged blackbird, he's probably not going to be able to get a mate in a high quality territory. Remember, red-winged blackbirds were the example of a resource-based polygyny species. So the dominant males are going to get by far the best quality territories and recruit more of the females. So if you can't make one of those males, just produce more females. In long term, that will be better for you. Now, older females, on the other hand, they can produce high quality eggs. They can be more efficient at feeding, and so they actually make male bias clutches. So that's what's being shown here, just what I described verbally. If you look at male versus females in a nest, young females clearly make a bias toward female clutch size. Middle age, it's about even. And then it's the opposite. Older females have a highly biased male clutch versus female clutch for the reasons described. House wrens do a similar thing. They're also polygynous. First mated females tend to fledge more and healthier young. They're probably higher quality individuals. They also get more of the male's parental help. So again, if we're talking about a polygynous species, what I mean by the first mated female, they join that male in his territory first, mate, establish a nest. He may recruit additional females, but that first mated female, she's got a head start. Probably she's a higher quality individual because she was mated first, but the male is already got more invested in her nest. He's more likely to contribute to helping that male compared to the second mated female. And so the first mated female, because of this extra help and because of the greater quality, tends to produce more females. Second mated female is probably not going to get any help, probably not as good quality female anyway. So if they did produce sons, they're not producing the sexy sons. They're producing sons that are unlikely to be successful, so they bias their clutch to produce more females. So biparental care really is important, but we did talk in the last lecture about if one parent dies, then the survivor can sometimes develop a brood patch. And if it's kind of late in introduction, in incubation. Solo parents, again, if their partner dies, may continue to care for the young, especially if they're kind of at later stage of development, almost to fledge. They may not be able to do it successfully. You may have some brood reduction, or the young may survive, have lower chance of survival, or fledging at a lower weight. And we'll see that fledgling weight is a good predictor of how successful they're going to be. So it can be costly. It can reduce their reproductive success. They may decide to bail on a nest because if it's going to be too costly, this current reproductive attempt could decrease their chance of future survival and reproduction. All right, let's talk about nest sanitation. We've been talking about bringing food to the nest, but with food comes waste. And the nest of some species do get fouled quite badly. The young will just defecate in the nest, and it gets pretty nasty. Bee eater nests smell horrible toward the end of the incubation period because they just defecate all in those burrows at the end of the breeding season. In some species, the nestlings will kind of hang their cloaca off the rim and try to defecate out of the nest. And you can see in this marbled murrelet nest here that at least they're trying to get it on the rim of the nest. But in passerines and in woodpeckers, the feces is actually encased in this gelatinous sac called the fecal sac. And the parents can do one of two things with this. They can eat it, and this is what they do, particularly with the nestlings that are just born. They're very inefficient at getting all the nutrients out of food, so there's quite a bit of nutrients still left in the fecal sac, and so the parents can actually eat that and recoup some of that. Or once it is just more waste, during later stages of nestlings developing these fecal sacs, they'll just carry it away and drop it well away from the nest to reduce, again, the odor and any visual signs of the nestlings being there. All right, so we've talked a lot about the behavior in the nest, and I did mention that there is a point when the young have to fledge. They have to leave the nest. And there's a cost-benefit ratio of staying in the nest too long versus leaving it just the right time to maximize the survival of the young and to maximize the lifetime reproductive success of the parents. So some of the factors that would go in to determine this cost-benefit ratio include what's the likelihood of predation in the nest if you're sitting ducks kind of thing versus if you're out of the nest. You need to make sure that you leave the nest as soon as you can so you're not a sitting duck, but not to the point. You still need to be mobile enough where if a predator attacks, you have some probability of escape. And also, once you start leaving the nest and traveling around the area, it's going to be a little more difficult for the parents to find and take care of those young, but it may be safer to do so. In this species, the yellow-eyed junco, there are 2 periods of low survivorship of the young. So the first 9 days, they can't fly very well once they fledge, and so they show about 50% mortality at this point. So when you first leave that nest, because you're not very mobile yet, you're still got a long way to go development, there is high mortality associated with that. The next period of low survivorship is associated with once they gain independence. So they've been fledglings for a while, but the mom and dad are constantly still bringing food to the begging fledglings. They start cutting that off just prior to independence, and if the young birds haven't developed their own foraging skills appropriately at that point, then that's another time period of high death because of starvation. So here's a fairly typical graph showing you that sure enough, the larger the nestling is, the higher their survival rate is when they fledge. This is an indication of how well they are developed, how mobile they are, what are their flight capabilities, and their abilities to find food and to escape predators. So you don't want to leave the nest too early. Nestlings in some aquatic species can kind of get away with leaving a little bit earlier and not be sitting ducks before they can really fly if it's relatively safe in the water and they can swim. Now, prior to fledgling, nestlings will practice and exercise their flight muscles to try to develop those flight muscles. But regardless, when they do first fly, it's usually quite awkward in species like osprey. Other birds, though, remember the swifts and swallows, these aerial insectivorous birds, they actually stay in the nest long enough that they're fairly well developed. They actually have more mass, remember. Their weight is actually greater than the adults. And so their first flights are actually quite capable. Some fledglings, it's pretty tough. I mean, some can, like nesting cardinals and jays and mockingbirds, the young can just kind of hop around, and they usually spend some time around the brush in the trees right around their nest for a few days. So it's not that big of a deal. Other birds have to leap from tall cliffs. So torrent ducks in South America, there are lots of videos that you can find online of torrent ducks and other waterfowl that nest in these types of steep ravines on these relatively safe cliff sides. But boy, when they leave these cliffs, they basically just end up bouncing down these cliffs, and it's amazing that they can survive these falls. So let's talk a little bit about what the young birds know. It's clear that they do have some innate, genetic-based, programmed understanding of what some of the dangerous things in their environment are. Chickens, despite the fact of being domesticated, still have this innate fear of brightly colored toxic caterpillars that are demonstrating some aposematic coloration. Aposematically colored coral snakes, again, stimulate naive mots into wariness. But learning is very important in young birds. So mobbing not only can help drive predators away from an area, it can also be a way that young birds can learn what the dangers are from older birds. Some birds learn from where they were raised what the appropriate nests are and what the appropriate nesting habitat is. We've talked about models being important for learning song in young males. And then just generally what's the appropriate habitat and foraging skills and foraging habitats and foods to eat are all things that tend to improve with age in most birds. One special type of early learning is called imprinting. Imprinting is seen in a lot of anseriforms. It's this learning of very specific things in a short period of time. In ducklings, it's usually between 13 and 16 hours old. That's when they associate movement and sound with individuals that they will then say, that's what I am. That's my parent. I am like you. And that will influence future patterns of sexual reproduction and species recognition. And this is why it's important for captive breeding programs to not get in the way of certain things like that. So California condors are, the reason that species is still alive in large part is due to some pretty intensive artificial breeding in captivity. And here we see a young condor that's in an incubator, keeping it warm after it's hatched. And instead of a human feeding this nestling with food, they use puppets that look like the heads of adult California condors. And then they use that to feed their young so that they can imprint on that image and not associate humans with food or potential mates in the future. So I mentioned the transition going from nest to out of the nest is the fledging stage. For most small passerines, a couple, 2 to 3 weeks. In scrub jays, it was usually around 4 weeks post-fledging. That's when they gain independence. So the parents up to that point have been feeding them pretty regularly, and that last few days they really avoid feeding the young. And if the young come up to them actually and start begging to try to get food, the parents oftentimes will attack them to get them to stop that and make that transition into independence. Now, species that have more specialized foraging skills or colonial species, this may be drawn out a little bit. And as I mentioned previously, this is, immediately out of the nest. The initial fledgling stage is a dangerous period and is associated with a lot of mortality. And then this a period of leaving your parents completely, they're not being dependent on your parents and being completely independent is also a time period in which there's a lot of starvation and death. And you're probably more likely also to be attacked by a predator if you haven't quite learned all of those threats yet. So there is some parent-fledgling conflict at this point. I mentioned, the fledglings are constantly still trying to get as much food as they can from their parents, but the parents will attack them if it's gotten to the point where, like, nope, you need to take care of yourself now. You're capable of doing it. And I, as a parent, have to think about my future survival and reproduction. I have little to gain by continuing to help you. You may continue to benefit from me constantly feeding you, but I have to be thinking about future reproductive success. Okay, so that's the last lecture on traditional kind of parental care. We're going to talk about two kind of associated topics, brood parasitism and cooperative breeding next week. So, see you then.